Hello everyone, welcome to my channel. Today, we are going to discuss what the difference is between a cheap and an expensive turbo engine. A turbo engine, or turbocharged engine, is an internal combustion engine equipped with a turbocharger, which increases power and efficiency by forcing more air into the combustion chamber. This allows the engine to burn more fuel and produce more power compared to a naturally aspirated engine of the same size. How a turbo engine works? Exhaust gases drive the turbocharger. The engine's exhaust gases spin a turbine in the turbocharger. Compressor forces more air into the engine. The spinning turbine powers a compressor which forces extra air oxygen into the engine. More air plus more fuel equals more power. With more oxygen available, the engine can burn more fuel, generating more power. Advantages of a turbo engine. More power. Increases horsepower without increasing engine size. Better fuel efficiency. Smaller turbocharged engines can deliver the same power as larger naturally aspirated ones, but consume less fuel. Lower emissions. Some turbo engines reduce CO2 emissions by improving fuel combustion. Here's a detailed comparison of cheap versus expensive turbo engines covering various aspects like design, performance, durability, and technology. 1. Turbocharger design and type. The turbo itself plays a major role in efficiency and performance. Cheap turbo engines. Single-scroll turbocharger. Basic design, where exhaust gases enter a single turbine. Fixed geometry turbo, FGT. Simple, cost-effective, but has turbo lag, which is a delayed power response. Smaller turbos provide power boosts but may struggle at higher speeds. Lower quality bearings, often use journal bearings instead of ball bearings, causing more friction and wear. Expensive turbo engines. Twin-scroll turbocharger. Separates exhaust gases for better efficiency and reduced turbo lag. Variable geometry turbo, VGT, adjusts vane angles to optimize boost pressure at all RPMs used in high-end diesel and performance cars. Electric turbochargers, uses an electric motor to reduce turbo lag, found in Mercedes AMG and Audi RS models. High-quality ball bearings, reduce friction, improve durability, and allow for quicker spool-up. 1. Engine materials and durability. High-performance engines use stronger materials to withstand extreme pressure and heat. Cheap turbo engines. Cast aluminum or cast iron blocks. Cost-effective but heavier and more prone to heat stress. Standard pistons and rods. Made of aluminum or steel but may not handle high boost pressure well. Basic cooling systems. May not include oil cooling for the turbo, leading to overheating and shorter lifespan. Expensive turbo engines. Forged aluminum or titanium components, lighter and more durable, capable of handling high boost levels. Reinforced pistons and connecting rods, prevents engine failure under extreme performance. Advanced cooling systems, features like liquid-cooled intercoolers and oil-cooled turbochargers improve engine longevity. Performance and power delivery is where the differences between cheap and expensive turbo engines really stand out. Expensive turbo engines focus on smooth, consistent power delivery, while budget ones may feel, well, sluggish. Cheap turbo engines often suffer from turbo lag, meaning it takes time to build boost, leading to delayed acceleration. They also have limited power output, as they are designed more for fuel efficiency than high performance. These engines usually have smaller displacement, commonly ranging from 1 to 2 liters, producing moderate power, around 120 to 250 horsepower. On the other hand, expensive turbo engines offer instant throttle response. Technologies like twin-turbo, variable geometry turbochargers, or even electric turbos minimize lag. They can handle higher boost pressure, delivering more horsepower and torque. These engines are larger and more powerful, typically found in V6, V8, or even W16 engines with over 500 horsepower. Think of models like the Porsche 911 Turbo or the AMG GT. Moving on to fuel efficiency and emissions. Expensive turbo engines use advanced fuel injection and emission control technologies. Cheap turbo engines come with basic fuel injection, usually standard port fuel injection, which is less precise than direct injection. They tend to have higher emissions, producing more CO2 and NOx due to inefficient combustion. Additionally, they are less efficient at high speeds, as the turbo may struggle to maintain boost at high RPMs. In contrast, expensive turbo engines employ direct injection and hybrid boost, optimizing the fuel-air mixture for better efficiency. They have lower emissions thanks to the use of catalytic converters, particulate filters, and even hybrid electric assist to meet stricter emission laws. These engines are more efficient at all RPMs, with advanced turbos adjusting boost dynamically to maintain power across the rev range. Now let's talk about reliability and maintenance costs. Expensive turbo engines are engineered to last longer but do cost more to maintain. Cheap turbo engines generally have a shorter lifespan. They are more prone to carbon buildup, turbo failure, and oil leaks. However, they offer cheaper maintenance as parts are widely available, making repairs affordable. Unfortunately, these engines experience more stress with higher pressure on weak components, potentially leading to head gasket failures or piston damage. Expensive turbo engines, on the other hand, feature better engine seals and bearings, which reduce oil leaks and extend turbo life. However, repairs can be expensive due to the advanced materials and precision engineering involved. With proper maintenance, some high-end turbo engines can last over 200,000 miles. So, which one is right for you? Choose a cheap turbo engine if you want affordable power and better fuel efficiency, need a daily driver and are okay with some turbo lag, and prefer low maintenance costs. Alternatively, choose an expensive turbo engine if you want high performance with instant throttle response. Need a durable, long-lasting engine with premium materials. Here's a list of cars with cheap turbo engines and cars with expensive turbo engines, categorized by price and performance. Cars with cheap turbo engines. Affordable and efficient. These cars use small, cost-effective turbo engines, mainly for fuel efficiency and moderate power. Budget-friendly cars costing around $20,000 to $35,000. Honda Civic 1.5T turbocharged i4, 180 horsepower, reliable, fuel-efficient but some turbo lag. Toyota Corolla GR, 1.6T turbocharged 3-cylinder 300 horsepower performance hatchback with an affordable turbo. Hyundai Elantra N-Line 1.6T turbocharged i4, 201 horsepower, sporty but the turbo isn't high-end. Ford EcoSport 1.0L EcoBoost, turbocharged 3-cylinder, 123 horsepower, basic turbo setup for fuel efficiency. Chevrolet Malibu 1.5T turbocharged i4, 160 horsepower, common turbo engine with simple tech. Volkswagen Jetta 1.5T turbocharged i4, 158 horsepower, good balance of power and economy. Affordable SUVs range from around $25,000 to $40,000. Here are some options. Ford Escape with a 1.5-liter EcoBoost, turbocharged Y3 producing 181 horsepower. It's efficient but lacks performance refinement. Hyundai Tucson with a 1.6T turbocharged i4 delivering 187 horsepower, a small turbo for an economy SUV. Nissan Rogue with a 1.5 TVC turbocharged i3 generating 201 horsepower. Innovative but not performance-focused. Mazda CX-5 with a 2.5T turbocharged i4 offering 256 horsepower. Good power but not a high-end turbo setup. Now let's talk about cars with expensive turbo engines where high performance and luxury are the key. These cars use advanced turbo technology for high power, better durability, and smooth performance. High-performance sports cars range from $50,000 to $200,000. Here are some notable mentions. Porsche 911 Turbo with a twin-turbo 3.8-liter flat-six producing 640 horsepower, legendary, near-instant turbo response. BMW M5 Competition with a twin-turbo 4.4-liter V8 delivering 617 horsepower, advanced cooling and twin-scroll turbos. Audi RS7 with a twin-turbo 4.0-liter V8 generating 591 horsepower, uses electric turbos for instant boost. Mercedes-AMG GT63S with a twin-turbo 4.0-liter V8 producing 630 horsepower, high-end ball-bearing turbos. Lamborghini Urus with a twin-turbo 4.0-liter V8 offering 657 horsepower, uses race-grade materials for durability. McLaren 720S with a twin-turbo 4.0-liter V8 delivering 710 horsepower, titanium turbochargers for extreme performance. Moving on to hypercars and ultra-luxury vehicles which range from $500,000 to over $3 million. These machines are the epitome of engineering excellence. Bugatti Chiron with a quad-turbo 8.0-liter W16 generating 1,479 horsepower, uses 4 turbochargers for seamless power. Koenigsegg Jesko with a twin-turbo 5.0-liter V8 delivering 1,600 horsepower, cutting-edge turbo tech for extreme speed. Ferrari 488 Pista with a twin-turbo 3.9-liter V8 producing 710 horsepower race-inspired turbocharging. Porsche Taycan Turbo S. Although electric, it's named Turbo and uses electric torque instead of a traditional turbo. So, which one should you choose? For daily driving and fuel savings, go for cheap turbo cars. For luxury, performance, and instant power, pick expensive turbo cars.